So we're going to study the second algorithm. First, we studied the Sutherland-Hodgman algorithm for polygon clipping. The second algorithm we're going to see is the Weiler or Atherton algorithm. Okay. So for this, why we are studying this algorithm, we'll see. So first, I would like to say, first we will talk about the disadvantage of our Sutherland-Hodgman algorithm. Okay, so you must be knowing that normally polygons you can have of two types. Okay, polygons are normally of two types. You can call them as concave polygons, and the other is said to be called as the convex polygons. Okay, you can have concave and convex polygons. So if you have a polygon of this shape, okay, so you can see that all shapes, all the angles, okay, which is said to be made within between your vertices, they're all inside 180 degrees. Okay, they're said to be less than 180 degrees. So such polygons, they're said to be called as the convex polygons. You call them as convex polygons. Now, if you have something of this particular shape, okay, if you have something of this particular shape, if you see the angle which is made here, okay, that is something which is said to be greater than 180 degree. So such kind of polygons are said to be called as the concave polygons. They are said to be called as the concave polygons. Now we studied about Sutherland-Hodgman algorithm. That is quite good for your convex algorithms, convex polygons, but they are not good for your concave polygons. Now why is it so? See that, we'll take a small example. Okay, so I'm going to draw imagine this is my clipping window. Okay, and my polygon is something like this. Okay, so I'll name the edges as A, B, C, D, E, F, G. Okay, the vertices have been named like that. And imagine this is a clipping window. You can give the name to the clipping window also. That is not required actually. We don't give much importance to that in Sutherland. We call this as C1, C2, C3, and C4. So you must be remembering how to solve this, isn't it? You may be remembering how to solve this. To solve this, what we do is, what do? We consider one by one. We consider edges one by one. As you can see that I'm going to do it with respect to one of my boundary, that is my left boundary. This is said to be called as out and this is said to be called as in. As I don't have any portion which is outside my upper boundary or lower boundary or my right boundary, you can directly write the steps, okay, using just my left boundary. If you see, we always process the edges in an anti-clockwise direction. So if I start from here, okay, if I take FE, okay, if I take FE, what do you see here? It is both the vertices are said to be inside the window. So I'll be considering my second vertex, okay, I'll be outputting my second vertex. Now I'm going to take the next edge that is said to be ED. It is said to be ED. So ED is, it is going from in to out. It is going from in to out. So what will be my output? My output will be the intersection of my edge ED with the left boundary of my clipping window. So I'll name it after the first vertex, that is E dash. So my output is going to be what? The intersection point, that is said to be E dash. Next, I'm going to consider my edge DC. Okay, I'm going to consider my edge DC. When I consider my DC, it is going from out to in. It is going from out to in. So when it's going from out to in, you will see that there is an intersection point. I can call it after the first vertex, that is D dash. Okay, and then the inside point C. So as it is going from outside to inside, I have to make note of the intersection point as well as the inside point. Now, which is the next one? The CB. Next is said to be CB. Both are said to be inside. Both are said to be inside. So I only consider the second vertex. Next I have BA. Next I have BA. Okay, next I have BA, that is into out. It is said to be into out. I'll only consider the intersection vertex. and it is said to be named after the first vertex. It is called as D dash. So I'll consider D dash. Okay. Next I have AG. I have AG. Both the vertices are on the outside area, so I don't consider any one of them. Okay. And then I have the next edge that is said to be GF. I have GF. Okay. So here what do I see? I'm going to see the intersection of this point, intersection of this edge with my clipping window, and we'll name it after the first vertex that is called as G dash. So as it is going from out to in, I need to make point of G dash and F. Okay, so this is the output vertices. Now how will I draw it again? Sorry. So this is my clipping window. Okay. So I have got the points looking at the output this thing. I have got the points B. I've got the points C. Okay. I've got the points D dash. I've got the points as D dash. I've got the point as D dash. I've got the point, next point is to be E dash. Then I've got my E. Okay. Then I've got my F. And I've got my G dash. So G dash to F, F to E, E to E dash. Okay. Then this. Then I have this. This is said to be called as C. This is called as B. Okay, so this is how I draw. Okay, this is my output. Now in this output, what do you see? What do you see? Is there an edge between D dash and E dash? Actually, is there an edge between D dash and E dash? This I have drawn because it is a part of my clipping window. That's why I have drawn it here. But is there an edge between D dash and E dash? It is not there, isn't it? It is not there. So this edge is said to be called as the extraneous or extra edge. Okay, this is said to be called as my extra edge. So my Sutherland-Hodgman algorithm, I get extraneous edges. I get extraneous edges. So I need to prevent this. Okay, I need to prevent this. And this only happens when you have a polygon which is of shape, which is having a concave shape, which is said to be having a concave shape. So as to eliminate this, we go with the algorithm that is said to be called as the Weiler-Atherton algorithm. Okay. Now in this we have a few terminologies that you need to know. Okay, the polygon. Okay, the polygon is said to be known as the subject polygon. Okay, the polygon is said to be known as the subject polygon, and the clipping window. Okay, and the clipping window. These are the terminologies which is used in this algorithm. So instead of saying clipping window, they call it as the clip polygon. They consider the clipping window as a clip polygon. Okay, and they have two types of list. One is said to be called as a subject polygon list, and the other is said to be called as a clip polygon list. Okay, one is said to be called as a subject polygon list, and the other is said to be called as a clip polygon list. Okay, so I'll tell you one which all list is said to be there. You have the subject polygon list, okay, which will be considering, you will understand later, which will be considering inserting intersection points, okay, which will be considering inserting intersection points. My handwriting is a little bad, okay. And second is said to be the clip the second name of the list is said to be called as the clip polygon list. Okay, it is called as clip polygon list, and that is going to consider your leaving. It is going to consider your leaving intersection points. It is said to be considering the leaving intersection points. It is going to considering the leaving intersection point. Now this you will understand only later in the algorithm. Why I have said it is considering the inserting intersection point and why it is considering the leaving intersection point. For time being, you just have to understand that you have two lists which is associated with this algorithm. One is said to be called as a subject polygon list and the other is said to be called as a clip polygon list. Now we'll take the same example as the previous one. Okay, and you have your clip window. Okay, this is said to be your clip window, and I'll name because the clip window, see in the previous case only the polygon was given importance, But here the clip window is also given, the clip polygon is also given importance. So we will name the vertices of it, that is C1, C2, C3 and C4. Okay. Now I'll draw my polygon. I'll draw my polygon. Okay, I've drawn my polygon. Okay, and I'll write the vertices of it as B, C, D, E, F, A, B, C, D, E, F, and you have your G. Okay, now this is what you have. So we are going to talk about the Weiler-Atherton algorithm, where we are going to consider the polygon. Our polygon is this particular polygon is said to be called as a subject polygon, and you have the clipping window, which is said to be called as a clip polygon, and you have two set of list which we're going to fill. Now, having all this in mind, what we do is we try to find the intersection points. Please remember, we try to find the intersection points of my subject polygon with respect to my clip polygon. So you can see that which are the points you can have. This is an intersection point, this is an intersection point, this is an intersection point, and this is an intersection point. Okay, and in your Weiler-Atherton algorithm, we always consider our edges in a clockwise sequence. So first I'll be taking AB. So the intersection point, I'll take it in terms, the intersection point is said to be named with respect to the first vertex, so I'll call it as A dash. Then I have my second edge as BC. Both are said to be inside. I don't have to think about it. Then I have CD. Okay, CD. Okay, so it is going out. Okay, so here I can name it as C dash. Okay, I can name it as C dash. Okay, then I have DE. So in DE, which is the intersection point, I can name it as D dash. Then I have EF, both the points are inside, I don't have to worry. Next, I have what? I'm having this particular edge, so I can name it after my first vertex. That is F dash. Okay. If you want, you can also name it as G dash, it is up to you, but let us have a sequence. That particular sequence has to be maintained. Now, once you have found the intersection points, okay, the intersection points of your subject polygon with your clip polygon. Please remember, once you have found the intersection point of your subject polygon with respect to your clip polygon, you need to write the subject polygon list. Now, what does the subject polygon list consist of? It consists of all the vertices. Of your subject polygon, okay, which also includes the intersection points. So if I start with A, I will be writing it as A, okay, then I'll write A dash, then I'll write B, then I'll write C. Please see the sequence. I'm going in a clockwise direction, okay. I have C, I've got C dash, then I've got D, then I've got D dash, okay, then I've got E, then I've got F, I've got F dash, I've got G, and I close my polygon, so it's a closed polygon, so I write my endpoint A also there. Okay, now that I have written my subject polygon list, next time I need to write the clip polygon list. What do you mean by clip polygon list? That is, I'm going to write all the vertices of my clip polygon. Along with the intersection points. So let us start from C1. Okay, let us start from C1. I'm starting from C1. Okay, then the next intersection point that I've got is F dash. Then I've got D dash. Okay, just look into the figure also correspondingly. You have got D dash, you've got C dash, you've got A dash, you've got C2, you've got C3, you've got C4, and I'm closing my polygon by saying C1. Okay, closing my polygon by saying C1. Okay. So please remember this. I'll write once again, or I'll write it here itself. Okay, because if I take in the next one, I'll have to copy it. It will be difficult for me. Okay, now keeping this points in mind, what did I do? First of all, I had my subject polygon, I had my clip polygon, okay, I found the intersection points of my subject polygon with respect to my clip polygon. Once I have done that, I create two lists. I am creating two lists. First list is set to be called as the subject polygon list, and the second list is set to be called as the clip polygon list. The second list is set to be called as the clip polygon list. So in the subject polygon list, I am writing all the vertices of my subject polygon along with the intersection points, So what are the intersection points? What are the vertices? I have A dash. You can subsequently, you can check in this also. I've got A, I've got A dash, I've got B, I've got C, I've got C dash, I've got D, I've got D dash, I've got E, okay, I've got F, I've got F dash, I've got G, and then I'm writing my A, okay. And now what about the clip polygon list? That is, I have to write about this polygon, clip polygon, okay. So not only the vertices of its clip polygon, I have to also write the intersection points. So how do I write? You can start from any point. Only thing is it has to be in a clockwise direction. Okay, both of them have to be dealt in clockwise direction. So I am writing it as C1. I have F dash, I have D dash, I've got C dash, I've got A dash, I've got C2, I've got C3, I've got C4, and then next I have C1. So I have done with this much. Now next, what do I do is I'll draw the direction of my edges also. I'm handling it in clockwise direction. So this is one. You will understand why I have drawn this. Okay. So considering the first one, okay, so you have to find out, see, subject polygon list will always start from the inserting intersection points. It means that all the edges I'm going to consider, my first point in this list, which is a point, which is the intersection point that I'm going to consider, I'll consider that one which is of an edge which is inserting into my clip window, or which is going inside my clip polygon. So if I see AB, okay, AB is going inside, okay, so I'll be considering that. And normally your clip polygon list will be actually stopping, it will be considering the first element will be the leaving intersection point. We'll see how it is. So in this case, my first point is A dash, so I'll start with here. Okay, this is my starting point. Okay, this is my A dash. So from A dash, I'll go to B. From A dash, I'll go to B. I have no problem there. Okay, it is an inside point. Then I go to C, I have no problem. Okay, from there, I go to my C dash. Now, what is the specialty of C dash? It is an intersection point of an edge. It is an intersection point of an edge which is said to be leaving my clip polygon, which is said to be leaving my clip polygon. Please remember, I will stop at a particular intersection. I'm going to stop at a particular intersection point of an edge which is said to be leaving my clip polygon. So C dash is said to be the intersection point which is said to be of an edge which is said to be leaving my polygon. So I'll stop here. Okay, I'll stop here. And then I'll find the corresponding C dash in my clip polygon list. That is going to be my first vertex in my clip polygon list. So where is my C dash? You can see here. Where's my C dash? Okay, my C dash is here. Okay, so you know that A dash and C dash, isn't it? A dash and C dash. So my starting was A dash. So from C dash, I'll go to next move. I'll go to my A dash and I'll stop there. Okay, I'm going to stop there. So keeping the sequence in mind, I'm going to plot, I'm going to write a sequence of vertices. Which will be called as my first vertex list. It is called as my first vertex list for my new clipped polygon. So here it starts with A dash, okay, then I'm having B, then I've got C, then I've got C dash, okay, C dash is again repeating so I don't write it, and finally I have my A dash just to show the closing way. So if you see the vertex list, okay, so you will be considering A dash, you will be considering B, you will be considering C, and you will be considering C dash, okay, and you can close that. Now which is the next vertex list? Which is the next vertex list? Again, I have to start with a I have to start with an edge. I have to start with an edge which is said to be inserting, that is, it is said to be going inside my, which is going inside my clip polygon. So if I see my edge DE, okay, I see my edge DE, so the first intersection point is said to be D dash. So that is going to be my next start point. So from D dash I'm going to travel to E, then I go to F because they are all inside my polygon, so I have no problem. But the moment I reach F dash belongs to what? It belongs to the edge which is said to be leaving my clip polygon. So that is the intersection point where I need to stop in my subject polygon list, and correspondingly F dash has to be found in my clip polygon list. So I'm going to find my F dash. Okay, I'm going to find my F dash, and from there I'll start and I'll stop at which particular point, intersection point, that is said to be D dash. So I'm going to stop here. So accordingly, I'll write my vertex list. It is starting from D dash. Okay. Then the next one, if you see here, it is E, F, E. I've got E. I've got F. I've got F dash. Okay. And F dash is repeated, so I'm not writing. I can write here D dash. Okay, so keeping this in mind, now do I have any other intersection point that I have to consider? It is G and A. G and A are both outside my clip polygon, and there's no intersection point. I always start from an intersection point and I end at the same intersection point in my clip polygon also. Now, using this vertex list, using the first vertex list and the second vertex list, I am going to draw my polygon. So first I'll draw my polygon window. Okay, I'm going to draw my polygon window. That is, I have my C1, I have my C2, this is my C1, okay. This is my C3 and this is my C4. So what are the points that I have from the first list? It says you have your A dash, then you have your B, then you have your C. So I'll draw this, okay. And then from C you have your C dash, and this is said to be formed. This polygon is said to be formed. And then you're having your D dash, you have your D dash. From there you're going to your E, then you go to your F, then you go to your F dash, okay, and the closing one. So is there that extra edge being formed between C dash and D dash which is not there? Is it there? That extraneous vertex is being formed? No, it is not formed. So in the case of your Weiler-Atherton algorithm, you can make use of it in both your convex as well as your concave polygons. But in the case of your Sutherland algorithm, you can only make use of it in your convex polygons. You cannot make use of it in concave polygons because you will have extra edges which are coming into the clipped window which is actually not there. Okay.